Okay, so second graders, we're here continuing our study on angles. And today we're going to learn about how to measure an angle. So I have a question for you. I'm using these fraction pieces, and this is a third. If I were measuring this and I wanted to measure the sides of the angle, what do you think I might use?
A ruler.
A ruler, right. So if we take the ruler and we measure the sides of the angle, it's about 2 inches here, about 2 inches here. Now, could I use the ruler to measure the angle?
No.
No, that's not going to work, is it? So we have another instrument to use to measure the angle, but before I show you what that is, I'd like to tell you a story. It's the story about a star. So a long time ago, there lived a group of people in this area. This is a map of Asia. In this area right here lived a group of people called the Babylonians. And they had a flourishing civilization with beautiful buildings. And their lands were prosperous and their crops were easy to grow. The lands were prosperous because of a certain reason. The name of this area, which they grew their crops, is called the Fertile Crescent of a land called Mesopotamia. And its name comes from the Greek. Meso means middle of, and potamus means river. So Mesopotamia means a land in the middle of 2 rivers. That is why the lands were so prosperous. They had 2 rivers to use for travel, for washing, for irrigation, and drinking. Today, Iraq, Syria, and Iran are right here. They used to be part of Mesopotamia. The 2 rivers are called the Euphrates and the Tigris. And its Greek name, Euphrates, is here on the left, and its Greek name means great river. The Tigris is on the right, and its name means, it's a Latin word for tiger, and so it means swift and very powerful. It was a forceful and wild river and it ran fast. The 2 rivers circled the city of Babylonia, and they empty into the Persian Gulf. Now, let's imagine that we're all together in the city of Babylon, and we have to go back in time over 3,500 years ago. The ruler was King Hammurabi. He was the first king that we know of who codified laws. Now we enter a main temple where the priests study and worship the moon and the stars at night. During the day, they worship the sun. These priests have a great project in which they're working. They're absorbed in their work, but they seem to be doing nothing. They're standing at the center of the temple in a place where there's no roof, and they're staring into the sky. What are they watching? What could they be looking at in the dark, looking up at the sky? What do you think?
The
The stars, yes. So they're standing there night after night, watching the stars travel across the sky. And where are the stars going? That's the same question that the priests have. They see the stars are moving very, very slowly, but certainly across the vault of the sky. After many years of watching, whenever the skies are clear, the priests learn something very important. Perhaps one priest watched one particular star his whole life, or maybe they shared the task, but they noticed that each star moved in an arc and in the same path. They noticed that a star might disappear for a while, but that it would always reappear in the same place and disappear in the same place. They noticed that the path of stars followed that the stars followed was the shape of a circle, and each star had to travel a certain number of nights in order to make a complete circle and return to the same point on the circle. The priests worked very hard to calculate how long it would take to finally arrive, and they finally arrived at the number 360, which is the number of days that was in the Babylonian year. We know today that there are 365 days in the calendar, but they were very close. Think of how hard it would be to work with such simple instruments of measurement to first discover that number. They were very clever, and they laid the groundwork for future studies. So, I'm going to show you, this is our Montessori Protractor, and this is a way in which we can measure that angle. So you can see if the stars traveled 360, the 360 is hid right under the 0. That's how long it took one star to make the path all the way around. So if we want to measure an arc or an angle, what we do, remember, this point here is the vertex. We learned that when we studied the angles earlier. So we take the vertex and we put it right here on this X. And we follow one line. This line we keep even with the 0. And the other side is going to show us the degree. We call that the number of days it took the star to travel this far would be 120. And today we call that 120 degrees. So remember, this fraction is 1/3. I'm going to send you paper that will have all the fraction pieces, and you're going to record on the first page, you're going to cut the fractions out. On the second page, you're going to record your answer. So this is 1/3. I would like you to write it out. And it equals, how much does it equal, Avery?
120.
Exactly, 120. And then we use a little circle to show degrees. So 1/3 equals 120 degrees. You're going to do this with all of the fractions. So I have 3 cards that I'll be sending to you. The first card has 1/3, 1/6, 1/9. And the directions say, print 2 copies of the fractions, cut one out, and record your answers on the other. So you'll write it just like I did here. This is 1/3, write it out in words, and the number of degrees it'll equal. Don't forget the little degree sign. Under each one of these, you're going to write the answer. Along with the cards, I'm also sending you a copy of the Montessori Protractor. And you'll also get a map of the Asia map to show you where the Fertile Crescent and Babylonia is. So I miss you guys. I hope we're back together soon, but I hope that'll give you some things to do while we're out. Thank you.